Okay, so let's see if we did this right. So we're going to FOIL the top and get 1 minus sine theta. On the bottom, 1 times 1 is 1. 1 times negative sine is negative sine theta. Positive sine times 1 is positive sine theta. Negative sine times positive sine is going to be a negative sine squared theta. The beauty of the conjugate is that this gets to go away. So now I have 1 minus sine theta. And on bottom I have 1 minus sine squared theta. And it said rewrite this so it's not a fraction. So if I were to write on the paper or on the board x squared minus 4, I truly hope that you would all say x plus 2, x minus 2. Well, this is no different. This is something squared, 1 squared, minus sine squared. So, sorry, you couldn't see, sorry. So let's do that. Let's do 1 minus sine theta. And on bottom, this is going to factor into 1 minus sine theta, 1 plus sine theta. Again, my favorite game, slashy washy. The 1 minus sine theta and the 1 minus sine theta get to cancel each other. Oh no, don't do that. I lied. That's going to take us right back to a fraction. Look, that's going to leave us with 1 over sine theta. So let's go back. Let's go back. Let's not factor, because I don't want to go backwards. Oopsies. Okay, let's do this instead. 1 minus sine squared. Well, earlier I told you if you ever saw a sine or a cosine squared and a 1, you should use your Pythagorean identity. So let's see if that will work. So I'm going to use this, and sine squared plus cosine squared equals 1. So if you subtract this sine over, 1 minus sine squared is cosine squared. So I'm going to have 1 minus sine theta over cosine squared theta. And that's still a fraction, but I can decompose this fraction, so to speak, and write 1 minus sine theta times 1 over cosine squared theta. 1 over cosine we know is called secant, so now I can rewrite this as 1 minus sine theta. And instead of just writing secant, because my cosine is squared, I'm going to write secant squared theta. And now I have fulfilled directions that said rewrite this thing so it is not in fraction form. That is not a fraction, so now I'm a winner. And I know you're like, oh, Gidry messed up. Well, that's kind of all part of this. In this Analytic Trig chapter, the best thing you can always do is to do something. Doing nothing obviously will get you nowhere, but doing something will either tell you that something you did got you down the right path or the wrong path. When I was doing this and I factored, I got back down here and I got back to 1 over sine theta, which is still a fraction. So that means that I should not have factored this. So now you have to go back to this step and decide what else can I do. Well, the thing we can do is change it into cosine squared, which then got me to the right answer. Oh my goodness. Trig and logs. Okay, so here we go. We can do this. When you're adding 2 logs, as long as the bases are the same, you can take the 2 things inside of the log and multiply them together. So I'm going to have ln, absolute value of cosecant theta times tangent of theta. And I have a single logarithm, so I've done this. It says rewrite this thing as a single logarithm. Check, done. But I have not simplified the result. So now I have ln, absolute value. Instead of writing cosecant, I'm going to write 1 over sine theta times tangent is sine theta over cosine theta. The sines get to cancel out or play slashy washy, so now you're left with ln of 1 over cosine theta, and 1 over cosine we know is called secant theta. And that is as simple as you can make your statement. Okay, so 1 through 7, all of the directions have said to simplify or to rewrite. Well, when we get to number 8, 9, and 10, the directions change to verify. And I don't need you to freak out because there's no reason to freak out. In fact, 8, 9, and 10 are better and, in my opinion, easier than 1 through 7, and here's why. 1 through 7, you are literally throwing a dart at a dartboard and hoping it lands somewhere. But on 8, 9, and 10, it is telling me, take this thing and make it this thing. So that's what I'm going to do. It's telling me what I need to do. It's telling me when I know that I am done simplifying. So I'm always going to pick the more complicated side, and I'm going to make it nice and pretty when I'm done and nice and clean like that. So on this side, on the left-hand side in this case, I have two fractions that have different denominators, and if I want to add fractions and they have different denominators, I have to find common denominators. So I'm going to multiply the first fraction by 1 plus sine theta over 1 plus sine theta, and I'm going to multiply my second fraction over here by 1 minus sine theta over 1 minus sine theta. And I hope you're smiling secretly because you're multiplying by a conjugate, so you know this is going to clean up. So on the top of the first fraction, I'm going to get 1 plus sine theta, and I'm going to FOIL this out. And the reason I'm foiling it out this time is because these are conjugates. I know that stuff is going to simplify. So 1 times 1 is going to be 1. 1 times positive sine is going to be a positive sine theta, and you're going to get a minus sine theta, and then you're going to get a minus sine squared theta. And it's going to be the same denominator over here. So I'm going to put a plus sign plus this numerator, 1 minus sine theta. And now we're going to clean things up. This sign and this sign are going to go away. This sign on top and the negative sign on top are going to go away. So positive sign and a negative sign cancel out. And then again on the bottom, this positive sign minus a sign cancel out. So now on top I have 1 plus 1 is 2 over 1 minus sine squared theta. And this is where you should be using your brain and using what you were given. I need to get to secant. Secant is friends with cosine, which means somehow I need to change this trig stuff into cosine. Well, again, you have a 1 and a sine squared, so that should be screaming at you, Pythagorean identities. If I move this sign over, 1 minus my sine squared is a cosine squared. So now I have 2 over cosine squared theta. 1 over cosine is secant, so I have 2 times 1 over cosine squared theta, which is 2 times 1 over, oh, no, not 1 over. 1 over cosine is secant, so when cosine squared on the bottom, it becomes a secant squared. And now you have 2 secant squared theta, which is this, and you have proven it. Yay, us. Okay, 2 more problems. Okay, number 9 says I need to verify that I have tangent plus cotangent, and that is going to equal secant times cosecant. Okay, so it says over on the side, identify the side you're going to work with, what side you're going to leave alone. I'm going to play with the left side this time, and I'm going to leave the right side alone, and this is why. It is easier, generally speaking in math, speaking from experience, to make plus and minus signs, quote-unquote, go away and become multiplication. Easier than it is to take this multiplication and go back to addition, generally speaking. So I'm going to start on this side. I cannot add tangent and cotangent together. They're not the same trig function, so I'm going to rewrite them. And when all else fails and nothing is squared, you should rewrite them in terms of sine and cosine. So I'm going to get sine x over cosine x plus cosine x over sine x. Again, these are fractions, and to add fractions, you need common denominators. So you're going to multiply the first fraction by sine x over sine x, and you're going to multiply the second fraction by cosine x over cosine x. So now you're going to have sine squared x plus cosine squared x all over sine x cosine x. Sine squared plus cosine squared is 1 over sine x cosine x, and now I'm going to break my fraction apart into 1 over sine x times 1 over cosine x. And I knew to do that because look, I have a secant and a cosecant. 1 over sine equals cosecant x. 1 over cosine is my secant x, and I have proven what I was supposed to get. Yay us. Okay. You are now going to, with a friend, try number 10, or by yourself, try number 10, and then go back to Edmodo and watch the very last video and see if you got the problem right.